Good morning, everybody. Welcome. The end of another week. We'll be starting in just a couple minutes. Mr. Finnegan has to stir his coffee. Exciting news today. Very exciting. Can you hear music playing? If someone could just type in yes or no that they can hear music playing, that'd be great. Then I know my audio is working. We went through this last class. You can't type no, because then I could say, can you hear music? And you type no, which means you heard me anyways. So no music. Gabby. Nice. Sorry, just tapping my coffee spoon. We're going to get started in 2 minutes. Morning, everyone. The 10 out of 27 of you. Very exciting. All right. We are back and ready to get started. It is 9 o'clock. Last assignment. Pretty good. 1, 2. Only 2 of you not getting it into me. So that's good news. These assignments all do count. So I'd like to go over a few things, a few exciting things. Exciting news is coming. I'll talk about that at the end of the lesson. But today we'll just go through. We'll go through our homework from last day. We'll go through the clock problem. And from there, we'll then expand a bit. I told you to start thinking about how to make equations off these things. So that's the new thing that's new for today. We'll do some more of that on Monday. And you will like Monday's lesson. You'll like the title of it. It says last lesson. More coming up on that in just a bit. By the way, that in the radio industry is what they call a teaser. They'll say, you ever seen something? Ever wondered how you can graduate? Well, come back after the break and we'll have more information. They tease you and then make you stick around. So actually, the big tease is not coming on Monday. It's today. Ha! See? Told you you'd be surprised. It is the last new class today. Today is the last thing I'm giving you that's new. If you know everything up to this point, all you have to do is learn today and you know everything. So here's the last new class, the last piece of new information, and then you are done Pre-Calc 12. And what are we going to do for the last 4 weeks, you ask? Glad you asked. I'll go through that with you. We only have, after today, I know this will be hard to believe, it's supposed to be 12 classes left online. Well, we don't. Let's see what we're going to do. We'll go over question 2 from the assignment last class. The Ferris wheel question was just like the one in the example. It was done very well. A couple of you started at the bottom, just like they did in the example. But if you remember, Rajabali started at the top. So you always look at where you start. And that's what we're going to do here as well. When it's 11:45, the hour hand's almost at the 12. So let's just follow this. So here's our first clock. It is 11:45, as they say, or 11:45. I know some of you can't tell time unless it's digital. Shame on you. You're in grade 12. It's pointing to the 9. Now look where that is in terms of the clock. As far as the height on the clock, when you're looking at the number 9, is that the very top of the clock? Is that the bottom of the clock? Or it's right in the middle? You see the 9's right in the middle. How is that hand going to move now? The next time it's going to go to, if we're making our magic points, notice at 12 o'clock. And I mentioned in the homework, pretend it's Mufid who's sitting on the end of that. And he's going now up to 12. Well, where's the height of the hand now? Now the height is at its absolute highest. And then it comes around. So now instead of being at the 12, now it's sitting at the 3. It's back to the middle. So, your hand on the clock has gone from the middle up to the top, back down to the middle, and then back to the bottom. And finally, a return. Now this return, it will come back to its spot at 9, but it won't do that until the future. It's almost like it's back to the future at 9. Great Scott. There we go. 9 up to 12, down to 3, down to 6, back up to 9. We're going to think about those points. So we were given some information about this clock. It starts right here. So we always think about where we started. We were told that the clock hand has a radius of 10. If the clock has a radius of 10, that means it's 10 up and it's 10 down. Super. We're also told that the bottom of the clock, not the middle, it's not the center. See, in the Ferris wheel question, I told you how far the center was off the ground. In this question, I told you how far the bottom of the clock is off the ground, and that's going to be 30 centimeters. So now you can look at your heights. If you are starting in the middle, how high above ground are you? Well, the 30 centimeters to the bottom of the clock, and then another 10 centimeters to the top of the clock, or to the middle, you're at 40 centimeters. So we think of where we start. Bam, that's it right there. We need to make some points for that. And our points are simple. When you start, time is at 0. A couple of you had a time start, your graph started at -3. Time graphs start at 0. You can always extend them back into the past, but in time travel, you can't actually go back into the past. It creates a flux in the space-time continuum. Can't do that. Great Scott! Okay, watch the movie if you don't get it. So there we go. We're starting at time equals 0. Look at the height. How high above ground are you? It's 30 centimeters. The clock's sitting on a wall or something, 30 centimeters up. It's a very small wall. And the radius is 10 centimeters. Your height is 40 off ground. Where do you go next? Now, the big hand goes up to the 12. So you think about that. How much time has elapsed? Time is now 15 because you put it in terms of minutes. Maybe you didn't put it in terms of minutes. Maybe you put it in terms of seconds. That's fine. But time is now 15. And how high above ground are you? 30 to the bottom of the clock, plus 10, plus 10. You're up now to 50. And away we go. When the hand gets to 3, time is 30. H is 40. We've now traveled for 30 seconds and we're back to the middle, or 40. Travel another 15 seconds. We're now down to the bottom. And when you're at the bottom, how much time has elapsed? Now we've gone through 45 seconds, and now we're exactly at the bottom of the clock, which we were told is 30 seconds off the ground. And then finally, we get back to where we started from. Time has been 60 seconds. We've completed one period of this graph. So what do we do next? Same thing all the time. So notice this question, exact same as the Ferris wheel question we went through. Exact same as all the time questions we go through. Take your situation, take your circle, add stuff onto it, whether it's radius or whether it's height above ground, where the center is, figure out what you know. Put the time things in there. How long does it take to go around this circle, through this cycle? And then plot those points. You got your points right there, 0, 40. And most of you have your homework out that you've looked at and that I marked already. 0, 40, 15, 50, 30, 40, 30, and away we go. Hi, Hallie. Sorry, there's a dog looking in through my window, wanting like a Scooby snack, waving her tail. Bye, Hallie. None today. I'm busy. Okay, sorry. Some of you are thinking, oh, go feed the dog. We can do math later. No, the dog has it. Okay, here we go. Here's our first step when we graph this. It's the same as what we did with the Ferris wheel. Draw your x-axis. Draw your y-axis. Now look for the points. Look at your x points. 0, 15, 30, 45, 60. You see them? I know you do. So we start at 0. That's the origin right there. And then there it is, 15, 30, 45, 60. Perf. Smurf. Now, look at your heights. We need a 40, 50, 40, 30, 40. We need 30, 40, and 50. A kablooey. 30, 40, 50. We are set to go. Same thing for this as the Ferris wheel. Figure out your circle. Figure out your first 5 points. Now plot those points. The Ferris wheel you got on the top, so at time t equals 0, you should have been at your maximum. This one, we start in the middle, the hand of the clock. So just think I might give you another one today to work on, but it doesn't start at 11:45 at 11:45. It might start somewhere else. So here it is. There's your first spot at 0:40. Then we go to 15:50. Now we go to 30:40, 45:30, and 60:40. And if you want, think of it just like you had the hand on a clock. Where did the hand on the clock start? Visualize. It was in the middle of the clock, and then up to the top, and then back to the middle, and then to the bottom, and then back to the middle, and then you could go another hour if you'd like. But in fact, time is eternal, so you can just keep making this graph forever and ever. Once again, start in the middle. You sine go up, sine go down, man. Look at that. It looks like a perfect sine graph. Just remember one thing, math fans. It's a curve. A couple of you lost marks again because you're still making straight lines. These are curves. Put it all together. These first 3 should look like the top half of a circle. These 3 at the end should look like the bottom half of a circle. And kablam, there it is. Now, because of the way the scale is, it looks like more like an oval, but curvy. No straight lines. That's what your graph looks like. Your x-axis, 15 to 60. Your y-axis, I did 10, 20, 30, 40, 50. That's why it's all up there. Looking amazing. So let's see what we can do now. Now the new stuff for today. And in fact, the last new stuff we are doing all year. What? Last stuff all year? Yeah, there is nothing new after this. After this, you have reached the end of Pre-Calc 12. So let's go, the 2020 edition. Here it is. Do we know what this point is? That's our maximum, and it has a y value of 50. Do we know where our minimum is? That's there. That's got a minimum value of 30. Why didn't I start at the beginning? Because when we're making an equation, what two things do we need to get A and D? That's right, max and min. Because if you remember, when we started talking about trig graphs, we figured out A. See, look up in the title, in the purple bar at the top of this. If you remember, this isn't sine divided by cos, it's sine or cos. I'm not a very good typer. I should have maybe put the cos after the word sine. So y will be A, which is your amplitude, and then either sine or cos, and then your B, your C, your D. We need to find A, B, C, D. Your formula for finding A, max minus min over 2. Great. Good thing we know our max and our min. That's going to be maximum 50, minimum 30. 50 minus 30 divided by 2. 50 minus 30 is 20. 20 divided by 2. Bam! A is 10. That's all we need to do is put an A equaling 10 at the beginning, and we are on our way to making our question. Do you remember the other one that was real simple to get with max and min? That would be D. That's the A and the D, the beginning and the end, the Y values, if that's transformations for you. So D, max plus min over 2. Max plus min over 2. You take your maximum value 50, add your minimum value 30. 50 plus 30, 80. Look at that, no calculator. 50 plus 30, 80 divided by 2. D must be 40. Amazing. We're halfway to getting our equation already. We've got A is 10. We got D is 40. Remember those quick, simple formulas. Max plus min over 2. Max minus min over 2. We can now put 10 in for A. We can put 40 in for D. And this beautiful equation, look what I've done now. I've put the 10 in for A. I've put the 40 in for D. Now this can be a sine graph or it could be a cos graph. What? Looks like a sine graph. Yes, it does, but it could be a cos graph. I'll show you. And of course, there is people trying to protect cosine graphs all around the world. I don't know you've heard them. A lot of people look for a sine, and the cosine people got very protective of that, which is why they started their own group. You may have heard of them, the Coast Guard, making sure you hear about it. Next time you're watching a movie and someone says, we should call the Coast Guard, it's just because there's been too many sine graphs used. Here it is. We've got 10. We did that max minus. It's the same whether it's a sine or a cos graph. We did the 40 at the end. It's the same if it's a sine or a cos graph. Let's see if we can find B. Any way to find B? We know B is always 2 pi over the period. Well, fabulous. Wish we knew the period of this graph. How long does it take? We started our clock handle pointing at 9. How long does it take until it points to 9 again? Kabam! It takes 60 minutes. With the Ferris wheel, it could take 24 seconds or 32 seconds. Something could happen in 4 days. Whatever the period is, you put that number underneath the 2 pi, and that's B. We can now take that 2 pi over 60, slap it in for B, and look what we've got. Now we've got our A and our D from max plus min and max minus min, both divided by 2. We've got our B by 2 pi over the period, and it could be a sine graph or it could be a cos graph. We don't know. Or do we? Oh, we know. Do you remember what the basic graphs look like? Look at the shape of this graph, and we're going to get our phase shift. Now, what I've put at the bottom, in the bottom left corner, you'll see a sine graph and you'll see a negative sine graph. That's just flipped over the x-axis. In addition, we have two more graphs. A cosine graph, that's the graph we were looking for in the Ferris wheel question on the homework assignment, because Rajabelli started at the top. And a negative cos graph, that's what we were looking for when Mufid went on his epic adventure, starting at the bottom. Now, what if you started in the middle of a Ferris wheel and the first thing it did is went up to the top? Well, now we'd be looking at a sine graph, the very first graph on those four, because now you're in the middle starting and going up. Remember what these four shapes look like. Sine. Does sine go up? Does sine go down, man? That's a sine graph. A negative sine, you still start in the middle, but this time you go down first and then up. Cosine graphs. Cosine always looks like the skateboard ramp. You're gonna ollie in and carve that gnarly rail, bruh. That's a cosine graph that does that. And then the negative cosine graph is just a upside down cos graph. Well, let's see what we have in our amazing shape. What if I start right here? If I imagine, which I am, that the graph starts here, what type of shape do you have? Notice you go up, back to the middle, and then back down. Doesn't that look like a sine graph to you? It does. So if it's a sine graph, you don't need any phase shift. This is the finished answer. The phase shift is the only thing that's a little tricky. We got the A, you got the B, you got the D. We're just working on C now. If you look at this shape, it is a sine graph. But what if I asked you specifically in the question, I want you to make it a cosine graph? Give me an equation in terms of cosine. Well, you just have to ask yourself one question. Where does a cosine graph start? Remember the pictures we just had. A cosine graph starts at the top. So now look at the second dot I've just put at the top of the graph. See how this could now be considered a cosine. Remember, this thing goes forever. So you're at the top of this graph. Now pretend you're starting at the top of this graph. Like the Ferris wheel question, what Rajabelli got on the top. What happens to this graph now? It starts at the top. It goes down to the middle, down to the bottom, back to the middle. It goes forever, so it's going to come back up to the top. Can you see this is a cosine graph? But look also where that point started. Look straight down from that point, and you'll see on the axis it started when x was 15. That's why this is also an exact equation for this graph. I could have 10, but if it's a cosine graph, cosine has to start at the top, and this top is at 15. Don't worry, this is the last new thing we're doing all year, and we will do this again next week. More information about next week coming. What if instead of a sine graph or a cosine graph, what if I asked you, make this graph in terms of a negative sine graph? What? Negative sine graph, yes. Where does a negative sine graph start? If you remember, negative sine graphs, okay, we'll just go back real quick. There it is. Remember these four things we had? Sine graph, sine go up, sine go down. Cosine graph, that's the third one over, starts at the top and goes down. Negative sine would mean you're starting in the middle and going down. Okay, we can do that. Start in the middle and go up, that's a sine graph. Start at the top, that's a cosine graph. But just make sure you put the phase shift in. Well, what if I start in the middle and go down? That's a negative sine graph. But I put the negative in front of the 10 to make it a negative sine graph. See how that's starting now at 30 seconds? I need my phase shift of 30. One left. I can actually make four different equations that all make the exact same graph. What if I very specifically said to you, put this in terms of a negative cosine graph. Where does a negative cosine graph start? It starts at the bottom and goes up all the way to the top, comes back down. So visualize, think of it. If I made it a negative cosine graph, what would my phase shift have to be? I've got it moving 45 seconds forward, so I would have that. All four of these equations, exact same thing. And that's it. You have now reached the end of Math 12. Of course, you would be able to brag about these graphs. You'd be able to tell me the amplitude, it's 10. You'd be able to tell me the period, it's 60. You'd be able to tell me the phase shift. It really depends on your equation. If you used equation number 1, there's no phase shift. If you used equation number 2, the phase shift is 15. If you used 3, the phase shift was 30. And if you used the fourth one, phase shift is 45. And then our vertical shift or vertical displacement for all of them is 40. You've got this. So here's how we're going to do all these questions. And then I'm going to tell you how we're going to finish off this year. First things, I'm going to give you word problems, giving you 2 more today for your weekend's activities. Sketch a circle. Fill in the radius on that circle, fill in the center, label it as far as all the time intervals, how long it takes to go around, everything else like that. Find your points, just like we did on the slide when we said when t is 0, h is this. When t is 15, h is this. You find all those points. And then plot those points onto a graph. Make sure it's curvy. No straight lines. Plot curvy points. Make it circular. That's right. This thing has no affiliation to any church. It's quite a circular graph. Then you make an equation from that graph, and that is exactly like what we just did at the end. Max minus min over 2. Max plus min over 2. 2 pi over the period, and then depending on where you start, you find the phase shift, and then you brag about that graph. That's your 2 questions that I'm giving you for the weekend or for later today. If you snap it up and do it right away, that will be fantastic. It's 10 marks because it's a bit of work for each one. I'm going to send you your assignment 14 today, and I'm giving you 72 hours to do 2 questions. Knock them down in the next hour or so, and you're good. Send it to me before Monday at 9. If it's after Monday at 9, we're going to have our next class Monday at 9. So we will have that class at 9 a.m. But before class starts next, you need to have these 2 questions handed in to me. Do it sooner than later, Logan, so that you don't miss out. So about our exciting news. You may have been hearing rumors that we are heading back to school. I'm going to let you know how this particular class is going to work. Next week is our last week of assignments. I'm going to be giving you 2 questions on Monday again. I think it's Monday. I'm giving you 4 questions. That's right. I'm giving you the week to do it. Our class next Friday, 1 week from today, will be our last online class. Sad, I know, for some of you. I'm looking at the comments and there's all these tears and sadness and oh no, Mr. Finnegan, say it isn't so. I'm looking at that and seeing all those comments that you guys are so sad. I know, it's sad. See, people are right now typing how sad it is. That's me. Okay, anyways, next Friday is our last online class. Then June 1st will start. And you say, what do we do June 1st, Mr. Finnegan? Well, we have 3 weeks of classes. June 1st starts. I'm giving you a logarithm review package for that week. And I'm giving you the answers for the logarithm review package that week. That week, starting June 1st, you review logs on your own. I will be at the school every day from 11 till about 2:30. And if you would like extra help with logarithms, if you would like a chance to come in and say, hola, well then, you just make an appointment. I'm allowed 6 students in a room at a time. You need to tell me, I'll have a sign-up sheet. You tell me when you're coming in. You tell me when you're leaving. And you have that much time to come in and get extra help. Your desk, after you use it, will not be used by anyone else again. All desks will be cleaned afterwards. Everything, there's no bathroom breaks. There's no set lunch hours. There's nothing. You come in and say, I need 20 minutes of your time. You got it. But there'll be no new lessons. That will be the first week of June. The second week of June, I'm giving you a review package on transformations. You're reviewing transformations for a week. I'm giving you the answers for it. You then, in that time, if you need extra help with transformations, I will be in my classroom. You make an appointment and you come in and see me. The third week, I'm giving you a trigonometry review package, and you're working on that. You will have chances for extra marks. If some of you have missed a couple assignments, you'll have chances to come in and do some activities that will give you extra marks. There will be no final exam in Pre-Calculus 12 this year. None. You can come in and we can talk about math. We can talk about your mark. We can talk about what you'd like. And I can tell you what I think your mark will be. And you can tell me that you think your mark should be something else. And we can discuss it. There will be no final exam unless you love final exams so much you're saying, please, please, Mr. Finnegan. Oh no, say it isn't so. And then I can give you a final exam if you'd like, but that's up to you. All right, I hope it's clear what's going to be happening. We do have class on Monday. I'm giving you an email today. You are asked to do your homework. I'm only giving you 2 more homework assignments. 1 today, 1 Monday. That's it. Finish strong, people. Don't bail now. Summer's almost here. We have next week online. Oh, well, hello, Logan. Nice to see you signing in. Class is over. Welcome. So you can watch the video again if you want to get some the exciting news. Last week is our last week of online learning. We will then have 3 weeks where I will be in the classroom and you will be making appointments to come see me. It's not mandatory at all. We can discuss your mark through email if you feel more comfortable. Until Monday then, I will bid you farewell. I'm about to send you your homework assignment now. Get it done right away, Logan, and I will talk to all of you Monday morning at 9. Until then, have a great weekend. Thank you, and good night from NBC News.